equation. It all starts with a simple question that was a real head-scratcher for physicists back in the 1920s. Why on earth does the electron spin? I mean, it acts just like a tiny spinning top, creating its own little magnetic field, but nobody had a clue why. It was this nagging mystery that pointed to a serious crack in the very foundations of physics. Okay, to really get what was going on, we have to rewind the clock to the early days of quantum mechanics. Physicists had these incredible new theories, but when they pointed them at the atom, something was off. The math kept giving them the wrong number of answers, and this puzzle hinted that they were missing something huge. In his 1928 paper, a guy named Paul Dirac gave this problem a name, the duplexity phenomena. That's just a fancy way of saying that reality didn't match the theory. Experiments consistently showed that the electron had double the number of possible energy states that the theory said it should have. Imagine your theory says a coin can only land on heads, but every time you flip it, it comes up heads and tails? That's how big of a problem this was. So, to try and fix this, two physicists, Goudsmit and Uhlenbeck, came up with a really clever patch. They just said, okay, what if the electron has this new built-in property we'll call spin? And this spin could have two states. You could call them spin up and spin down. Well, that instantly doubled the number of states, and voila, the theory suddenly matched the experiments. It worked, sure, but it felt tacked on. It didn't explain why spin was there to begin with. And this is where our hero, the brilliant Paul Dirac, enters the story. He was not satisfied with this quick fix. As he wrote himself, a real answer shouldn't need arbitrary assumptions. He believed the reason for spin wasn't some extra feature you just add on. It had to come from a deeper, more fundamental truth. See, Dirac had a hunch. He suspected the real problem wasn't the electron at all, but the theories we were using to describe it. He saw this epic conflict brewing between the two pillars of modern physics, a real clash of titans that somebody had to solve. On one side of the ring, you've got quantum mechanics, the bizarre, wonderful rules that govern the tiny subatomic world. And in the other corner, you've got Einstein's special relativity, the laws for things moving incredibly fast, near the speed of light. The problem? They didn't play nicely together. There was no single theory that could handle something that was both very small and very fast, like an electron. Now, people had tried to mash them together before. This equation right here, the Klein-Gordon equation, was the best shot they had. But honestly, it was a mess. It was riddled with problems, giving totally nonsensical answers, like predicting negative probabilities. That's like saying there's a negative 20% chance of rain tomorrow. It just doesn't work. Dirac knew they needed to start over. In his paper, Dirac pinpointed the fatal flaw. The old equation wasn't linear in time. Now, without getting too bogged down in the math, what that means is that it broke a fundamental rule of quantum mechanics, that if you know everything about something right now, you can determine its future. This old equation allowed for multiple different futures from a single present, and that was a complete deal breaker. So, Dirac's mission was crystal clear. He had to build a brand new equation from scratch, one that obeyed the rules of both quantum mechanics and special relativity. And he was guided by this deep, powerful belief that the laws of nature at their core must be mathematically beautiful. And his logic here was just a masterclass. First, he insisted the equation had to be simple and linear to satisfy that quantum rule. Second, he demanded that if you squared his equation, it had to magically turn into Einstein's famous energy-momentum relation from relativity. But when he tried to do it, he hit a brick wall. Regular numbers just wouldn't work. So what did he do? He basically had to invent a new kind of math on the spot. Instead of normal numbers, he realized he had to use these grids of numbers called matrices, specifically 4x4 matrices, to make all the algebra work out. It was a totally wild but brilliant move. And this is what he came up with, the Dirac equation. It looks so simple, right? It's so compact and elegant, yet it perfectly marries the two warring worlds of physics. This is, without a doubt, one of the most powerful and beautiful equations ever written down. But the real question is, what secrets was it hiding? And this right here is the heart of the story. Remember, Dirac wasn't trying to explain spin. He was just trying to get these two big theories to get along. But his equation, it seems, had a mind of its own, and it was about to reveal something absolutely incredible. So the big question is, what happened when he actually used it? What happens when you apply this shiny new equation to a real-world problem, like an electron buzzing around in a magnetic field? Well, the result was bigger than anyone, probably even Dirac himself, could have ever imagined. So Dirac does the math. He solves his equation for an electron in a magnetic field, and the math itself just spits out these extra little pieces, these two extra terms that you can see highlighted in his original paper. They weren't in any of the old theories. He didn't put them there. They just appeared right out of the logic of his equation. One of those extra terms described a magnetic moment. And as Dirac himself wrote, with his typical incredible understatement, this magnetic moment is just that assumed in the spinning electron model. There it was. The equation had found the missing piece all by itself. I mean, just let that sink in for a second. Dirac did not put spin into his equation. He just demanded that quantum mechanics and relativity be consistent with each other, and the equation gave him spin for free. It wasn't a patch. It wasn't a fix. It was a fundamental consequence of the very fabric of reality. And he wasn't done. The equation also predicted the exact amount of spin, a value of 1/2. This was the final piece of the puzzle. Every single experimental detail of that whole duplexity phenomena was now perfectly explained. Not by some arbitrary guess, but by the fundamental laws of the universe. You can imagine the impact of this was absolutely monumental. Dirac's beautiful equation didn't just solve one nagging problem. It threw open a door to a much, much deeper understanding of what reality even is. So just think about what this one equation did. It unified two of the greatest theories in physics. It explained where electron spin comes from, right from first principles. It solved that whole duplexity puzzle without any weird fixes. But it held one more, absolutely mind-blowing secret. The math also predicted a perfect mirror image particle to the electron, identical in every way except with a positive charge. This was the very first prediction of antimatter. And that just leaves us with this incredible thought. Paul Dirac showed us that just by demanding that our theories be mathematically beautiful and logically consistent, you can actually uncover fundamental truths about the universe, things that experiments haven't even found yet. It really makes you wonder, doesn't it? What other profound secrets about our reality are still just sitting there, dormant, waiting to be found inside the next beautiful equation?